moving on to question 4 here. If we know that a side has a bigger median and a bigger mean, then we know that side has the older people, okay, or older players, or the bigger side, whatever, okay? So in this case, we're talking age. So because the males have a larger median and the larger mean, we know that the males are older in this case, okay? So if one side has the bigger mean and the bigger median, we know that side is older, okay? Or has the bigger whatever number we're talking about, okay? If one has the bigger mean and the other side has the bigger average or median, that doesn't tell us much. But if both of them have the bigger one, then we know we can go with that. So next thing we're going to talk about are outliers. And outliers are numbered that are pieces of data that are far away from the majority of data, okay? So if we're looking at the data set 1, 2, 3, 4, and 25, 25 would be an outlier because most of the data is between 1 and 4. If we found the median of the data, it would be 3, but the mean would be 7. These are so far apart because of the outlier. Usually we like the mean and median to be fairly close together. Now it seems like 4 isn't really that big of a deal, but if we're talking about something specific, that can be a major difference. Okay, so sometimes when we're looking at data, we'll take out the outlier and calculate the mean. So if we were to calculate the mean without 25, okay, we would do 1 plus 2 plus 3 plus 4, all divided by 4 because there's 4 numbers. So that would be 7, 9, 10. 10 divided by 4 is what do you guys think? So 10 divided by 4 would give me 2.5, which is significantly closer to my 3 that I originally had for my median, right? And actually, if we do the median of 1, 2, 3, 4, that is also 2.5. So they're exactly the same. So if we take out that 25, our mean and our median become very close together. So sometimes in data, we'll throw out a weird person, okay? So let's go back. We'll do another quick stem and leaf plot here, okay? And we're going to look at some outliers, okay? So we're going to start by finding the median of the data, okay? So again, that's my middle number, so I'm going to start crossing off my things here, okay? And I get stuck in the middle with 22, okay? And then we're going to find the mean, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8 total numbers, so I'm going to divide by 8. And we're going to add them all up here, so I'm going to erase my little marks here so I can see my numbers. So we're going to have 11 plus 12 plus 20 plus 22 plus another one plus 24 plus 28 plus 54, which would be 193. Gotta get my writing tool out here. And 193 divided by 8 would be approximately 24. So the average length of salmon right now is 24 inches, and the median length is 22. So when we're looking at this, that's still fairly close together. But when I'm looking at this, I do see an outlier, okay? So I can say, well, the average and mean are pretty close, but we might need to look at it without the data, or without the outlier, I'm sorry. Okay, so that's kind of what we're looking for with number 3. Now with the range of data, again, I'm going to do the biggest minus the smallest. So we have 54 minus 11, which would be 43. Okay, so that range, that's a very large range of data if we're talking about lengths of salmon, right? 43 inches between the biggest and the smallest. It seems like most salmon in an area would kind of grow about the same length, okay? So how does that outlier affect the range and the mean? So if I take out the 54 and pretend it's not there, the range becomes 28 minus 11, which is only 17 inches. That seems a little more realistic for a fish, right? 17 inches, maybe there were some babies in the group, maybe some had stunted growth for certain reasons, but 43 inches is kind of crazy. Now the mean, if I do that, I'm going to do 193 minus 54, because that would take out the 54. So it would be 139. And that would mean there's only 7 numbers. So if I added all these up and then divided by 7, 139 divided by 7 is 19.8. Okay. Now in this case, it didn't have too much of an effect because here we were about 2 inches away. And here we're actually a little bit farther away. Okay. But that does change how we look at things. Okay. So sometimes it's just better to take out the outlier because it just throws off the data. Sometimes you need to look at both pieces of data to see, does it really affect it that much? 28 and 54 aren't, too far away if we're talking about inches, but it can affect the data massively, okay? So just be prepared. Sometimes you will need to take out that odd data point, okay? So be on the lookout for that. Hopefully this is helpful. We will see you guys